This is going to be the first of two videos on how to use and apply the Rational Zero Theorem. Now, before I get into the theorem itself, I did want to just give a couple quick refreshers on some vocabulary we'll be using. When we're talking about polynomials, sometimes I'm going to mention the degree, which is the biggest exponent on your variables in the entire expression. Usually this should be the one out front, but sometimes the question will try to get tricky and it'll move that biggest exponent somewhere else and have it out of order. Next, we have the constant term. This is the number by itself with no x's or variables attached to it at all. Usually it is the very last one, but sometimes, again, they may get tricky and put it in a different order. And then the last definition I want to talk about is the leading coefficient. This goes back to the term with the biggest exponent, but instead of it being the exponent itself, now we're talking about the coefficient in front of that number. It should be the very front number. If you don't see a number in front of the x cubed or whatever the largest x is in this case, then that means that that coefficient is a 1 if no number is written there. And then we're going to talk about some synthetic division. Sometimes I'll be referring to the quotient of a synthetic division. That means the numbers that you have underneath here that I circled in red. We also may refer to the remainder. Generally, we're going to be hoping for a remainder of 0. Well, the remainder is that last number here at the very end underneath the synthetic division. And when I refer to a 0, I'm specifically referring to a number that you may have tested with synthetic division that gave you a remainder of 0. If you get any other number for a remainder, then it's not a 0 of the polynomial, and the number that you're testing is the 0 itself. So I'll say, was it a 0? The 0 is the number that you tested with synthetic division. So now let's look at the actual rule for finding our list of possible zeros. We're going to look at 3 different types of questions, but first we're going to begin with the possible zeros. Now, the possible rational zeros are the ones that if we plug them in for x, the polynomial will end up equaling 0. We're going to find the ones that are possibly the correct answers by looking at the factors of the constant term and the factors of the leading coefficient. So basically, we're going to have a list of numbers on a numerator, and we're going to have a list of numbers for a denominator. And then we're going to create a list of all the numbers that might be zeros by picking combinations of numbers from the numerator and denominator. Make sure you consider the positive and negative for every single number, every fraction that we consider, and always simplify your fractions. Now, sometimes when you're simplifying your fractions, you'll get 2 answers that are identical. 4 over 2 and 2 over 1 both equal 2, but we wouldn't write 2 as a solution twice. So here's our first example. We have a polynomial given, and we are right now only focusing on the possible rational zeros. We'll talk about the ones that are actually zeros in a little bit. So the list of possible rational zeros, that means I want to focus on the constant, and the factors of that number right there, well, 1 times 8 or 2 times 4. Those are my factors of the constant. If I'm talking about the factors of the leading coefficient, my number in the very front in this case, the only numbers that go into 2 are 1 times 2. So what we want to do is create a list where the numerator is the factors of the constant. So I'm going to write for myself that my possible zeros are plus or minus 1, 2, 4, and 8. Those are the numbers I'll put in the numerator. 1, 2, 4, and 8. And then in the denominator of the fraction, we put the factors of the leading coefficient. That was the 2 in this case. So my only factors of 2 were 1 and 2. So this sets up our list of possible zeros, but now we want to see how many ways we can pick numbers from the numerator and denominator. So my actual list of possible rational zeros, you want to try and be as detailed in this process as possible. Personally, I like to start with the first number on the numerator, and then I like to put it over all of the numbers in denominator, however many you have. So I'm going to have 1 over 1, 1 over 2, and then that's all the numbers in the denominator. So now I go to the next number in the numerator. So now I would say 2 over 1 and 2 over 2. And then I go to the next one. That would be 4 over 1, 4 over 2. And then one more time, 8 over 1 and 8 over 2. Now, many of these fractions can be reduced. So if I was to simplify some of them, we don't need to write 1 over 1, for example. That would just be 1. Well, 1/2, that's a new number. We don't have that one yet. 2 over 1 is a new number. 2 over 2 is equal to 1. I already have 1 listed in my list of possible zeros, so I don't need to write it again. So I'm going to skip that one. 4 over 1 is a new number. 4 over 2 reduces to 2. That's already in my list. 8 over 1 is a new number. And then 8 over 2 equals 4. That is also already in my list. So my list of possible rational zeros is plus or minus 1, 1/2, 2, 4, and 8. I'm really not going to care too much about the exact order you put them in. Sometimes I see people like to put all the whole numbers first. Sometimes I see people like to list them from least to greatest. Generally, your assignments all allow you to put them in any order as long as you're getting all the numbers. Now let's talk about which numbers from that list are actually zeros. We helped narrow it down a lot. We know it's not any number imaginable, but now we want to know which ones actually give us 0 when we plug them in. So the first step was kind of just about narrowing down which numbers we need to test. Now what we're going to do, and this is just for degree 3 polynomials, when I ask you to find the rational zeros, not the possible zeros, but the actual rational ones, we're going to start with the list of possible rational zeros we just found. And then we're going to use synthetic division on the numbers from that list until we find one with a remainder of 0. As soon as we get one with a remainder of 0, we should be able to switch to factoring the quotient, and then that will get us the other 2 zeros. So if it's a degree 3 polynomial, you should expect there to be 3 answers. That's why if we find 1 with synthetic division and 2 with factoring, we'll know we have found all of the answers. Later on, we'll look at degree 4 or even larger polynomials when you might have to find 4, 5, or even 6 answers. So we'll do a couple examples of this now. Now the first step requires me to go back and start with a list of possible rational zeros. So I still need to find that list. So we're going to repeat the exact same thing we already did by stating the factors of 6, which are going to be 1, 2, 3, and 6, over the factors of 1. This is great news. This happens a lot. When the first number is a 1, then you don't really have to do as much work with finding all the possible combinations of one number from the numerator and one number from the denominator. You can just say, well, it's going to be plus or minus 1 over 1 is 1, 2 over 1 is 2, 3 over 1 is 3, and 6 over 1 is 6. That's great. We don't have any fractions. This happens on many of the questions, especially earlier on the assignments when you're dealing with easier ones. So now I know that these are the 8 possible numbers that I'm going to be testing with. So how do I do the testing process? Well, the idea is that we pick one of those 8 numbers and we try to do synthetic division with it. Now first I'm going to show you what happens when you choose incorrectly. So for synthetic division, I'm going to pick the positive one from my list, and the coefficients of my polynomial here are 1, 2, -5, and -6. The first number comes straight down, and then I multiply and put that into the next column. Now I just add the numbers in the column, and I continue to repeat this process. Add the column, multiply by the number in the box, add the column. I did not get a remainder of 0. So what that means is that this was not one of the zeros of the polynomial. So I chose 1. What we may want to do instead is pick a different number, like -1. So we're going to go back, and we're going to try this again, but we're picking a different number from the list. So sometimes you might get kind of unlucky, and you might have to try several times before you find the right one. So this time, my first number comes down. I get 1. I multiply by the number in the box. I add the numbers in the column, multiply by the box, add the column, multiply the box, add the column. Remember, that last number is our remainder. And I did get a remainder of 0 this time. That's great. So what I know is that -1 is one of my answers. The other answers are going to come from this part down here. This is 1x squared plus 1x minus 6. So what I should do at this point is just factor to find the rest of the answers. So if I factor this expression, I'm looking for 2 numbers that multiply to -6, but add up to a +1. Let me do this. Yeah, I'll do this underneath. So my factoring is still going to be x times x equals x squared. But for numbers that multiply to 6, I'm going to use 3 and 2. And I need it to be a +3 and a -2, so that the numbers actually add up to a +1, even though they do multiply to -6. Now, the other factor that I have right now comes from the 0 we just found. So this also creates a factor front. But don't forget that if the 0 is -1, the factor is going to have the sign flipped on it. it's actually going to be x plus 1, because I want to make sure that if I set that factor equal to 0 and solve the equation, the answer it gives me should be the negative 1. So this is my factored form of my zeros. The question may ask for it in factored form, or they may just ask for the list of zeros. That's the more common way this is done, in which case my zeros were the negative 1 that I found from synthetic division, and then the other two that I found from factoring. Don't forget to solve those factors. It would be negative 3 and positive 2. Again, the order isn't going to be something I will stress too much, so as long as you list the numbers, you'll be correct. Let's do one more example of this. I'm going to find another list of possible zeros. So I'm abbreviating that just by saying possible zeros. Don't forget that it's plus or minus for these numbers. My factors of 2 go on top. Factors of the constant go in the numerator. The factors of the leading coefficient go in the denominator. So the factors of 3 are just 1 and 3. This one's a little bit uglier. I do have some fractions I may have to consider. So I have 1 over 1, 1 over 3, 2 over 1, and 2 over 3. So again, I have 8 possible numbers because there's the 4 numbers I see with a positive sign in front and those same numbers with a negative sign in front. So I have 8 numbers altogether. Now again, we want to test numbers from the list. I recommend not testing the fractions first. Try to do all of the whole numbers as much as you can. A lot of times I just start by trying like the 1 and the negative 1. Those are usually the easiest numbers to test. So if I plug in positive 1, my polynomial has coefficients 3, 4, negative 5, and negative 2. The first number comes down, multiply by the 0 I'm testing, add the numbers in the column, multiply the 0, add the numbers in the column, multiply the 0, and add the numbers in the column. So that one worked again. If I hadn't gotten remainder 0, I would just erase it, and I would pick a different number from the list and try again. This time I'm going to be factoring the 3x squared plus 7x plus 2 expression that I have there. Now, if I wanted to write the other part in factor form, this would be x minus 1 out front because positive 1 was my 0. But right now, I'm really just more interested in finishing this factoring piece off. So this is the harder factoring trinomial case. I know that my first numbers need to multiply to 3x squared, so it has to be 3x and 1x. And I know that my last numbers have to multiply together to equal 2. Now, I'm going to put the 2 here and the 1 here, because I know that I need the outside product and the inside product to add up together to equal 7x. And so what I'm looking at is that right now, the way I have these numbers set up, this will be 6x, and this would be 1x. Those do add up to 7x. So those are my factors for the trinomial that I gave. Don't forget to solve those factors, though. So my 3 factors are the x minus 1, the 3x plus 1, and the x plus 2. If you set each of them equal to 0 and solve, the first one is the positive 1. We already knew that one from synthetic division. This one I would be subtracting 1 and then dividing by 3. So it's negative 1/3. And then this last one would be subtracting 2 from both sides of the equation. So it's negative 2. So my 3 zeros are negative 2, negative 1/3, and positive 1. And that's it. That's the list of rational zeros. Easiest thing to confuse on this is not noticing when they ask for the list of possible zeros and the list of rational zeros. If they just ask for the possible ones, you're stopping way up here. If they ask for the rational zeros, then you need to find which ones from that list are actually correct and then factor to find the rest. And that's it for the first lesson. Thank you.